This tutorial will look at uploading data into the RStudio Cloud website, calculating some summary statistics on that data, and then looking at producing some basic box plots. So first we'll create a new project. Our first goal is to get the data uploaded into the RStudio Cloud space. This is pretty easy to do as long as you know where your data file is stored on your laptop or computer. So after RStudio Cloud opens, I'm placed directly into a default project folder here where I have two basic files. I want to upload my data file. I will choose the file to upload, and it's going to be my classdata.csv that's sitting on my desktop. Hit open, hit OK. That just uploads the data into the cloud. It doesn't actually read the data into R for me to do my analysis. So that's the next step. The command I need is going to be read.csv. And what I'll have to do is pass it a string with the file name. That's just classdata.csv. Because the class data file is in my current directory, I can just write the name there. If this file were somewhere else, I would have to type the full path in here. This is important if you're using a local copy of RStudio, and when you open up RStudio, its default folder is your home folder, but if your file is sitting on your desktop, you'll have to put in a full path, something like tilde/desktop/classdata.csv. This would work on a Mac or on a Linux laptop. So we don't need that here though. Let's read the data. I see I have 21 records, data for 21 subjects. I have 3 variables recorded: age and years, heart rate and BPM, and favorite sports. Note that spaces and parentheses in the column headers turned into periods here in the R labels. So because I didn't save that data to an actual variable, I'll have to do this a second time. I'll create a variable class data for reading this data into. And this time I'm also going to pass a second option, col.names, so that I can rename my columns. First one will be age, then heart rate, then sport. Oops, typo. You find yourself making a typo and get an error, you can get your previous command by typing the up arrow. We'll get the whole command back. Call names. Note up here in my environment, I now have a variable, class data, that involves 21 observations of 3 variables. This class data is not a vector of data, it is a data frame. So if I type class data here, I see I've got age, HR, and sport. I have my new labels, just how I wanted. Unfortunately, because this is a data frame, I cannot manipulate the whole data frame at once here. It's not what I want to do. I'd like to look at individual variables within this data frame, say the heart rate. So I can access just the column of heart rate data by typing class data $, and RStudio says that there's 3 variables defined in this data frame. So I can select one of them here. We'll do heart rate. And if I hit enter, now I get the vector of numerical heart rate values that I might want to then summarize, manipulate, visualize, what have you. Now if I'm going to do a bunch of manipulations with just this data, I might want to also define a new variable, just call it HR, that is this class data HR. So this way I don't have to type class data $HR all the time. I can just type HR instead. So some basic summary statistics. The mean heart rate, 74.5. The variance of the heart rate, 109.4. Variance and standard deviation here are both calculated for a sample. So it uses a denominator of n-1. Standard deviation is 10.5. Note that I could have just calculated the square root of var of HR and gotten the same answer. Finally, it's easy to calculate a median as well of a data vector. If you're interested in the 5-number summary, that's called the summary command. I get the minimum value, the first quartile, the median. I also get the mean, third quartile, and then the maximum value. So now that I've investigated the data set by calculating some summary statistics, and I want to visualize the data set. And instead of creating a histogram, I'm going to create a box plot. The basic command is boxplot, HR. Note that it defaults to vertical box plots, so that makes this squeezed a little bit here. So a common thing to do, especially if I only have 1 or 2 box plots I'm visualizing, is to type in horizontal equals true. Looks a little better. Recall from class that this is the minimum value, this is the first quartile, the median's over here, the third quartile, and the maximum. By default, R produces a modified box plot, so if there are any outliers, you'll see those identified here as well. I can add axis labels and titles just like I did with histograms in a previous video. So I might set main be equal to class heart rates. I have no reason to label the y-axis here, but the x-axis label could be heart rate BPM. And let's add a color of red. Much better looking box plot. However, box plots are more useful if I want to visualize a set of data broken down into subgroups. So what I mean by that is if I go back to my class data, what if I wanted to look at the distribution of heart rates but broken down by favorite sport? Meaning I want a box plot of heart rates for people who like basketball and a different box plot of heart rates for people who like soccer and so forth there. There are 2 ways of doing this. One would be the long way to create 5 different data vectors simply by looking at this here and saying, okay, who are the football people? 66, 80, 80, 68, etc. going down. But there's a better way. If I type question mark box plot, look at the help command here. What we used before was boxplot, and then X is the data vector. There's also the version of boxplot with a formula you can pass in. So this is down here, a formula such as y tilde GRP group, where y is a numeric vector of data values to be split into groups according to the grouping variable GRP. That's precisely what I want. And then this is data, a data frame or list from which the variables and formulas should be taken. All right, so let's do this. I would like to do a box plot of HR broken down by sport, and the data is class data. Here I get 5 box plots. Some of the labeling is missing just due to spacing issues with basketball and football. Do note that some of the box plots look a little strange. Like for baseball here, there's just one subject, yours truly, who picked baseball. And so my heart rate of 88 was the only one listed there. So I just get this single line. Now I could go and do some labeling on this as well. I could do X label is favorite sport. Y label is heart rate in BPM, and then also a main title, class heart rates by favorite sport. That looks a little bit better. On homework 2, what students are asked to do is to go back to our class data set and do precisely the same thing, but instead of breaking the heart rates down by favorite sport, instead you want to break down the heart rates via whether the student was younger than 30 or 30 or older. Now the challenge with that is we need a categorical variable that we don't have that corresponds to, let's say, true, student is under 30, or false, the student is not under 30. So we actually need to go and create that variable here. One simple way of doing that is as follows. I can always take my class data and define a new variable called under 30 and set it equal to something. Now the issue is, what do I want to set it equal to? I want to get maybe true or false. I could do yes or no as well. We'll do true or false here about whether a student is under 30 or not. And what's interesting is that I can get this assignment real easily. I need to map ages to true or false. So if I do class data age, I see if I type less than 30, it's going to go down and give me a vector of Boolean values, true, falses, about whether or not a given age was less than 30 or not. It's exactly the information I want. So what I want to do is I want to go to class data, define this new variable under 30, and what I'm going to assign it to is the result of class data age less than 30. So now if I type class data, I have a new column under 30 filled with true or false. 28 true, 30 false. All these ages in the 20 are true, 31 false. It's exactly what I want. So now I have a new categorical variable that I can then create a formula to break the heart rates down between these two groups. And just make sure then when you produce the box plot that everything is labeled appropriately.